In this video, I am going to discuss about the mechanism of Kolbe's reaction, or which is also called as Kolbe-Schmidt reaction. It comes under phenol topic. It's a very important name reaction. So this is nothing but phenol. When phenol reacts with sodium hydroxide, now the H plus and OH minus, H plus from phenol and OH minus from sodium hydroxide will be removed as water, so minus H2O, which results in formation of a compound, benzene ring with ONA. So what you call it as sodium phenoxide. The name of this compound is sodium phenoxide. When sodium phenoxide reacts with carbon dioxide under a condition of 400 Kelvin temperature and 427 bar pressure, it forms this compound, what we call it as sodium salicylate. The name of this compound is sodium salicylate. Now this sodium salicylate on acidification, in presence of acid such as hydrochloric acid. So what will happen is that COONA portion is converted into COOH. Actually that Cl will be added over Na and H will be added over here, so that this group becomes COOH. So finally you are getting a compound which in which benzene ring carries OH group and COH group in adjacent carbon, ortho derivative, so which is called as salicylic acid, and is also called as orthohydroxybenzoic acid. It's also called as orthohydroxybenzoic acid, because here this is considered as a parent compound. So benzene with COH group, which is nothing but benzoic acid, and there is a OH substituent, so hydroxybenzoic acid. The carboxyl and hydroxyl groups are in adjacent carbon, so it's a ortho derivative, orthohydroxybenzoic acid. So formation of this salicylic acid from phenol using sodium hydroxide and carbon dioxide followed by acid hydrolysis is what we call it as Kolbe reaction. Okay, so this is a net reaction. Let us see how the product is formed in steps, which is nothing but the mechanism. Okay, right. Now this is nothing but phenol. First phenol reacts with sodium hydroxide. Now what will happen is sodium hydroxide produce OH minus ion, isn't it? Now this OH minus ion will abstract this hydrogen as proton. Then this H plus will combine with the OH minus and will be removed as water. By the time the bond pair between oxygen and hydrogen will be moving towards oxygen, so that oxygen becomes O minus. Oxygen becomes electron rich. Now that results in formation of this compound, a compound benzene ring with oxygen carries minus charge. What you call it as phenoxide anion. The name of this substance is phenoxide ion, or exactly phenoxide anion. Okay. Then this phenoxide anion has resonance structure. It has resonance structures, so structure like this. Now what is happening is this oxygen atom being electron rich, now these electrons are moving between this oxygen and carbon. By the time the pi electrons which are present inside the benzene ring moves to this carbon atom. So that when the electron over oxygen moves over here, you get a new double bond. You get a new bond here. When this pi electron moves over here, that carbon becomes an electron rich center, or that carbon attain negative charge, which means this carbon is becoming electron rich. Okay, right. Now both these are nothing but phenoxide ion, but we call it as resonance structures. Okay, right. Now this second form of phenoxide ion, this one will react with carbon dioxide. Okay, so this is a structural formula of carbon dioxide. Oxygen being more electronegative can be given a negative charge, and carbon will be given a positive charge. Here the carbon is electron deficient center, isn't it? But now what will happen is this electron rich carbon can attack the deficient carbon of carbon dioxide, okay, or otherwise that electron which is present over this carbon will be shared with this carbon atom of carbon dioxide, so that a new bond will be formed between this carbon and benzene ring carbon, okay, right. By the time, so what will happen is this bond pair moves to oxygen, so that it becomes single bond O minus. That's what. So now for this, the driving for this, now so what is happening is, so you are getting a new bond between this benzene ring and carbon atom, and already you have a hydrogen also in this carbon, isn't it, right? Now, so what will happen is this hydrogen, when this bond between carbon and hydrogen moves inside, it forms a normal benzene ring. By the time one of this bond pair moves to oxygen, so it becomes single bond O minus, single bond O minus. Then once this bond moves inside, this hydrogen will come out as a proton. That proton is getting added over this oxygen. O minus H plus is nothing but OH. So this whole portion will become as COH group, okay, right. So now you are getting this substance. Now at last what will happen is that compound undergoes acidification, in presence of water, okay. Now in presence of acid, so what will happen is that H plus ion produced by the acid is getting added with this O minus ion, so that this portion becomes OH, okay. So finally you are getting a product in which benzene ring carries OH group and COH group in the adjacent carbon atom, an ortho derivative, what we call it as salicylic acid, okay. So this is the mechanism of salicylic acid or orthohydroxy benzoic acid, okay. So a very simple and important mechanism, okay, right. Thank you.